When determining electrical box fill, a crucial aspect is understanding the volume allowance for devices like receptacles. A standard residential 15-amp receptacle requires a specific cubic inch allowance within the electrical box. The National Electrical Code, or NEC, provides guidelines for calculating box fill to ensure safe and compliant electrical installations. The NEC specifies that each conductor, device, and fitting within a box contributes to the total box fill. Understanding these requirements is essential to prevent overheating and potential fire hazards. The cubic inch allowance for devices like receptacles is based on the wire size connected to them. For example, if a 15-amp receptacle is wired with number 14 American wire gauge or AUG conductors, the cubic inch allowance will be different than if it's wired with number 12 AWG conductors. The general rule for device fill is that each single GAN device, such as a switch or receptacle, counts as two conductors based on the largest conductor entering the box. However, this doesn't directly translate to cubic inches. Instead, the NEC specifies a cubic inch allowance based on the wire size. To determine the cubic inch allowance for a 15-amp receptacle, you need to consult NEC Table 314.16. This table provides the minimum volume required per conductor based on the wire gauge. Since a receptacle is counted as two conductors, we'll need to multiply the value from the table by 2. Let's consider a scenario where a 15-amp receptacle is wired with number 14 AWG conductors. According to NEC Table 314.16, the minimum volume per conductor for number 14 AWG is 2.0 cubic inches. Since the receptacle counts as two conductors, the total cubic inch allowance for the receptacle would be 2 times 2.0, which equals 4.0 cubic inches. Now let's consider a different scenario where the 15-amp receptacle is wired with number 12 AWG conductors. According to NEC Table 314.16, the minimum volume per conductor for number 12 AWG is 2.25 cubic inches. Therefore, the total cubic inch allowance for the receptacle would be 2 times 2.25, which equals 4.5 cubic inches. It's important to note that these are minimum values. You must ensure that the electrical box you select has enough total cubic inch capacity to accommodate all the conductors, devices, and fittings within the box, including the receptacle. Failing to do so can lead to overheating and potentially dangerous situations. To calculate the total box fill, you need to consider several factors. Firstly, count all the conductors within the box. This includes all insulated wires, even if they are not connected to a device. Secondly, add one conductor for all the ground wires combined. Regardless of how many ground wires are present, they only count as one conductor for box fill calculations. Thirdly, add one conductor for all the equipment grounding conductors entering the box. Similar to the ground wires, equipment grounding conductors are counted as one conductor in total. Fourthly, add the appropriate conductor count for any devices, such as switches, receptacles, or dimmers. As mentioned earlier, each single GAN device counts as two conductors based on the largest conductor entering the box. Fifthly, add any additional conductors for internal clamps or supports, if present. Some boxes have internal clamps that require additional conductor allowances. Once you have determined the total conductor count, consult NEC Table 314.16 to find the minimum box volume required for the number of conductors based on the largest wire gauge present. Make sure the electrical box you select has a cubic inch capacity that meets or exceeds this minimum requirement. It's always better to choose a box that is slightly larger than necessary to provide ample space for wiring and avoid overcrowding. Overcrowding can make it difficult to properly install devices and can increase the risk of damaging the conductors. In addition to the conductor count and device allowances, it's also important to consider the volume occupied by any cable connectors or fittings within the box. These fittings can take up significant space, especially in smaller boxes. Be sure to factor in their volume when calculating the total box fill. When working with electrical wiring, always prioritize safety. Turn off the power to the circuit before working on any electrical components. Use properly insulated tools and wear appropriate safety gear, such as gloves and eye protection. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. Improper wiring can lead to electrical shocks, fires, and other hazards. The NEC is a comprehensive set of standards and guidelines for electrical installations. It is updated regularly to reflect the latest technologies and safety practices. It's important to stay informed about the latest changes to the NEC and to follow its requirements when performing electrical work. Many local jurisdictions also have their own electrical codes that may be more stringent than the NEC. Be sure to check with your local building department to determine the applicable codes in your area. Understanding box fill calculations is a crucial skill for anyone working with electrical wiring. By following the guidelines in the NEC and taking the time to properly calculate box fill, you can ensure safe and compliant electrical installations. Remember to always prioritize safety and consult with a qualified electrician if you have any questions or concerns. The NEC Table 314.16 provides valuable information about the minimum volume required per conductor. The table lists various wire gauges and their corresponding cubic inch allowances. For example, number 14 AWG typically requires 2.0 cubic inches per conductor, while number 12 AWG requires 2.25 cubic inches per conductor, number 10 AWG requires 2.5 cubic inches per conductor, number 8 AWG requires 3.0 cubic inches per conductor, and number 6 AWG requires 5.0 cubic inches per conductor. When determining the box fill for a receptacle, remember that it counts as two conductors based on the largest wire gauge connected to it. This means that if you have a 15 amp receptacle wired with number 14 AWG conductors, you will need to allocate 4.0 cubic inches for the receptacle. If it is wired with number 12 AWG conductors, you will need to allocate 4.5 cubic inches. It's important to note that these are minimum requirements. You may need to use a larger box if you have a lot of conductors or devices in a box. In addition to the conductors and devices, you also need to consider the volume occupied by any cable clamps, connectors, or other fittings in the box. These items can take up a significant amount of space, so it's important to factor them into your calculations. When calculating box fill, it's always a good idea to err on the side of caution. If you're not sure whether a particular box is large enough, it's better to use a larger box. Overcrowded boxes can be difficult to work with and can increase the risk of damage to the conductors or devices. Always follow the manufacturer's instructions when installing electrical boxes and devices. The instructions will provide important information about the proper installation techniques and any specific requirements for the product. If you are unsure about any aspect of electrical wiring, it's best to consult with a qualified electrician. Electricians have the knowledge and experience to safely and properly install electrical systems. Working with electricity can be dangerous, so it's important to take precautions to protect yourself from electric shock. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate safety gear, such as gloves and eye protection. Never work on electrical systems in wet or damp conditions. If you are taking on a DIY electrical project, be sure to do your research and understand the relevant electrical codes and regulations. The NEC is a good starting point, but you should also check with your local building department to see if there are any additional requirements in your area. The electrical work can be challenging, but it can also be rewarding. By taking the time to learn the basics of electrical wiring and following the proper safety precautions, you can safely and effectively complete many electrical projects around your home. Remember to always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Understanding the requirements for box fill is critical for ensuring safe and reliable electrical installations. The NEC provides detailed guidelines for calculating box fill, including allowances for conductors, devices, and fittings. By following these guidelines, you can avoid overcrowding electrical boxes and reduce the risk of overheating, short circuits, and fires. The cubic inch allowance for a 15 amp receptacle as determined by the NEC, is dependent on the Y gauge used. This is a fundamental aspect of electrical safety and code compliance. Accurate box fill calculations are not just a matter of adhering to regulations, they directly impact the safety and longevity of electrical systems. Neglecting these calculations can lead to hazardous conditions, including overheating and potential fire risks. Therefore, it is imperative to understand and apply the NEC guidelines correctly when working with electrical boxes and devices. This knowledge is essential for both professional electricians and homeowners undertaking DIY electrical projects.